Hello guys, so our today's topic is gonna be functional groups. So let's begin. Introduction, like what exactly are functional groups? Now, the atom or the group of atoms by which the characteristics reaction of organic compounds are determined are called functional groups. Basically, functional groups contain hydrogen, nitrogen, sulfur, phosphorus, and oxygen. Now, there are some common functional groups which we're going to explain throughout this PPT, and they are alkane, alkene, alkyne, alcohol, ether, nitrile, and aldehyde. And there are some more which we're going to see in the next slides. So, to begin with, there's a brief introduction that what does function group do. So there has to be a certain kind of reactivity or like a certain reaction in the organic molecule for its introduction. Like what exactly are functional groups? Now, the atom or the group of atoms by which the characteristics reaction of organic compounds are determined are called functional groups. Functional groups contain hydrogen, nitrogen, sulfur, phosphorus, and oxygen. Now, there are some common functional groups which we're going to explain throughout this PPT, and they are alkane, alkene, alkyne, alcohol, ether, nitrile, and aldehyde. And there are some more which we're going to see in the next slides. Begin with, there's a brief introduction that what does function group do. So there has to be a certain kind of reactivity or like a certain reaction in the organic molecule for it. Now we begin with our very first functional group, alkanes. You can clearly see that there are only two atoms used here, carbon and hydrogen, and carbon are forming a single bond. So therefore, whenever any atoms are forming a single bond, their name ends with ANE. Therefore, the organic structure of this compound can be called as ethane. Now we move on to our second functional group, which is alkanes. Here also, only carbon and hydrogen atoms are present. But the thing here is that a carbon to carbon are forming a double bond. Therefore, their name ends with ENE. Whenever there is a double bond, the name should end with ENE. Therefore, the organic structure of this compound is called ethene. Now we move on to our third functional group, which is alkynes. Same as the previous ones, here also carbon and hydrogen atoms are present. But the thing here is that a carbon to carbon atom is forming a triple bond. And whenever there's a triple bond, the name ends with YNE. Therefore, the organic structure of this compound is ethyne. On to the fourth functional group, we have alcohols. Alcohol has an OH group which can be classified as 1, 2, 3 according to the position of OH group on carbon skeleton. They are named as alkanol, and therefore the organic structure of this compound is ethanol. There is more to alcohol as there are three types of alcohols: primary, secondary, and tertiary. Primary is when there is no carbon attachment to the carbon atom, it is called primary. Secondary is when carbon gets attached with two carbon atoms, it is called secondary. And tertiary is when carbon gets attached to three carbon atoms, it is called tertiary. On to the next functional group, we have aldehydes. It has a C double bonded O group. C double bonded O group is at the end of the carbon chain attached to H on one side, CHO. CHO group is always attached at terminal position, and they are named as alkynyl. And therefore, the organic structure of this compound is called as ethanol. On to the next functional group, we have ketones. Ketones has a C double bonded O group. C double bonded O group is not at the end of carbon chain. They are named as alkanon, and therefore the organic structure of this compound is propanol. On to the next functional group, we have esters. Esters have a carbonyl group bonded to an alkoxyl group. Onto the organic structure of this compound, O is linked to C double bonded O group, not at the end of carbon chain. Therefore, they are named as alkyl alkanoate, and therefore the name of the organic structure of this compound is called methyl ethanoate. On to the next functional groups, we have carboxylic acid. Carboxylic acids have a carbonyl group bonded to a hydronyl group. It has two oxygens, O single bonded H and C double bonded O groups on the same carbon atom. This COOH group has to be at the end of a carbon chain, and they are named as alkanoic acid, and therefore the organic structure of this compound is ethanoic acid. The next functional group that we're going to study is ether. Ether has one oxygen but no O single bond H or C double bond O. The oxygen is sandwiched between two carbon atoms. Their name ends with ether. So the organic structure of this compound is called as ethyl methyl ether. The next functional group is amines. Amines and alcohols have a similar kind of a fact, which goes like, just as alcohols are considered as organic derivatives of water, amines are considered as organic derivative of ammonia. Now on to the organic structure of the compound. It has an NH2 group and it can be classified as 1, 2, 3 according to the number of carbon atoms connected to the end. They are named as alkanamine. So the organic structure of this compound can be called as ethanamine. Amines can be classified into three groups, and this classification is based on the number of organic groups that are attached to the nitrogen atom. The first one is primary. Primary is attached to only one organic group. Then there is secondary. Secondary is attached to two organic groups. And then there is tertiary. Tertiary is attached to three organic groups. The next functional group is amide. Amide has NH2 linked with C double bond O group, and they are named as alkanamide. So the organic structure of this compound can be called as ethanamide. On to the last functional group of this presentation, we have haloalkanes. Haloalkanes have the general formula R single bond X, where R is an alkyl group and X is a halogen, and they are named as haloalkanes. So the organic structure of this compound is called chloroethane.